Hi dear students, you are welcome at Jakhar Chemistry YouTube channel. Myself R. Jakhar. Today we will discuss a chapter liquid solution. So let me start. Solution. First of all, definition of solution. A homogeneous mixture of two or more compounds is known as solution. So do remember this definition. Here the term homogeneous mixture is necessary. Now, what is the meaning of term homogeneous or homogeneous mixture? Homogeneous mixture. You know, if you are having a mixture of two compounds like aqueous solution of NaCl. Here we can say there are two components in this mixture. One is water and another is NaCl. If we see this solution or we observe this solution in the transparent vessel, then we cannot identify the separate molecules of NaCl and water by our naked eyes, and this mixture is known as transparent mixture, or we can say homogeneous mixture. Now, types of solution. Solution can be classified on the many bases, in which first we are taking on the basis of number of components forming a solution. So in types of solution, in first case we are taking number of components forming a solution. On the basis of number of components forming a solution, the types of solutions are as binary solution, trinary solution, quaternary, solution, or we can say polynomial solution. So now we are defining these one by one. First, binary solution. A solution formed by two compounds, or we can say here two components are present in solution. Then solution is known as binary solution. In this chapter, in most of the cases, we will discuss binary solutions. Similarly, in case of trinary solutions, there are three components in solution. In case of quaternary solution, there are four components. In polynomial, more than four components are present. So this is a simple classification of solution on the basis of number of components forming a solution. Now we will discuss binary solution in detail. In case of binary solutions, we are mixing two compounds to form a solution or homogeneous mixture, and in which one component is known as solute and another as solvent. Okay, and these two form solution. In case of binary solutions, we are having two components in the solution, in which one is known as solute, another component is solvent, and these are forming a solution. Now, criteria to determine solute and solvent. Here the criteria to determine solute and solvent is relative amount of components. If a component is having relatively more amount, then it is known as solvent, and a component having less amount is known as solute. And here to remember, amount is measured in moles. So we can say more number of moles for solvent and less moles for solute. So this is criteria to determine solute and solvent. Now by mass conservation, what we can say? In case of binary solutions, we are having two components, solute and solvent, and when we mixed, there is formation of solution, and by mass conservation we can say mass of solute plus mass of solvent will be equal to total mass of solution. Mass of solution. Okay. So now what the meaning of this and how can we use this in numerical problems? For example, if you have given a solution that is 100 gram and we know that we are mixed 80 gram of solvent. So can you say mass of solute? So we can determine easily. Let x gram of solute is mixed here with 80 gram solvent to form 100 gram. So you can say x plus 80 equals to 100. So x will be equals to 20 gram. So you can use these informations in wall chemistry and in all numerical problems. This is one case. Now, properties of solution and properties of components. What is the relation between these properties and how can we determine or decide the properties of solution? Here we know that the amount of component which is more is known as solvent. So maximum properties of solutions are closer to properties of solvent. So do remember, maximum properties of solutions are closer to properties of solvent, and some properties of solution are different also. First, if you are having these two components in different physical state, then physical state of solution is always similar to physical state of solution is always similar to that of solvent. Similar to solvent. What is the meaning of this? If we are having a solid solute and liquid solvent, then we are getting liquid solution. Similarly, if you are having a liquid solute and solid solvent, then physical state of solution will be solid. If you are having a gas solute and liquid solvent, then solution will be liquid. So we can determine in this way. So to remember, physical state of solution is similar to that of solvent. And most of the properties of solvent are closer to solvent also. Now, here we are having two components in binary solution to form a solution. So there are so many conditions in which we have to determine the solute and solvent. So what are the conditions we are discussing here? Here we are saying that more number of moles component is solvent and less number of moles of component is solute in binary solution. So if in a solution we are having both the components in equal amount or equal number of moles, then how can we determine solute and solvent? So in such a case, you have to check the physical state of both components. If both components are having different physical state, then solvent component will be that which is having physical state similar to solution. Okay, and if number of moles are different, then we can see by number of moles the solvent component and solute component. So first criteria is mole. If number of moles are equal, then we have to see physical state also. Now another question. If you are having two components and both are having equal number of moles and similar physical state, then we have to observe, or we have to see the maximum number of properties of solution is closer to which component, that will be solvent. And another case, if two components are having equal number of moles, similar physical state and similar properties also, so in that situation you can take any one component as solute and another as solvent. So do remember this thing. So in case of binary solution, you can face this type of problems. Now we are taking a question. We are having a homogeneous mixture of water and NaCl and water. And in this mixture, you are given information as 20 gram of NaCl and 15 gram of water are given to form a solution. In this case, you have to determine which component will be solute and which will be solvent. So you have to identify solute and solvent, and you have to determine the physical state of solution also. Physical state of solution. So this is the question you have to solve, and you can give your answer in comment box for this question. The question is, again I am repeating, a mixture is having 20 gram of NaCl and 15 gram of water in a binary solution. You have to determine the solute and solvent component and what is the physical state of solution. Okay, so now discuss next, trinary solution. In case of trinary solution, there are three components which are forming a solution, and if you want to determine solute and solvent components here, then what is the criteria? So here you can remember, if we are having any solutions like polynomial solutions, then solvent component is always 1 and all other components are solutes. So what about trinary solution? So in case of trinary solution, there are two solute like solute A plus solute B and one solvent like solvent C and forming solution. Okay, so do remember, for any solution or polynomial solution, solvent component is always 1 and all other components are solutes.